Good day. Thank you for watching this video and studying your math with me. This video addresses partial fraction decomposition. As usual, my examples are different than those in the book, and so both should be read and studied. Watch this video carefully to understand every step. It can be paused, rewound, and reviewed as needed. Ask questions to fill any gaps, and doing some homework is always a good thing. So let's do some math. The idea with partial fraction decomposition is to take a rational expression that is difficult to do calculus with, perhaps impossible, and change it into a form equal to it, but it is called the partial fraction decomposition. It is not unlike factoring. You can multiply factors together to get a trinomial, for example, but you can take a trinomial and break it into its factors. Both things are useful. We will also talk a little bit about a technique called the Heaviside cover-up technique. This is what he looked at, and this can be useful in solving some of these problems without as much effort. So the first step in partial fraction decomposition is that if the degree of the numerator is greater than or equal to the degree of the denominator, you have to use long division. Only the remainder, which has the denominator having a higher degree, will be subjected to further partial fractions decomposition. The answer, however, will be the sum of the quotient and the remainder. We then factor the denominator completely into products of linear factors, perhaps of multiplicity greater than 1, and irreducible quadratic factors, perhaps of multiplicity greater than 1. These irreducible quadratic factors are those who have complex roots. And it is possible, and this is the entire case because of the theory we studied in Chapter 3. Now the following table should be committed to memory and is in Blackboard. Basically, each linear factor of the form ax plus b will generate a term in the partial fraction decomposition called capital A, a constant, over ax plus b. Every linear factor of multiplicity k will generate a sum of terms that look like this, where the powers will run from 1 up to k. Every irreducible quadratic factor will generate a term not only with a constant, but ax plus b over that quadratic factor, and likewise this can be to a power k, and again it will generate a sum of terms looking like this. This is summarized a bit more here in the table that is contained within your notes, and these top two have opportunities to use the Heaviside cover-up technique, and we'll talk more about that later. So let's do this first example. So first we should factor the denominator. And we know from the theory this can be written as a over the first factor plus b over the second factor. Now this is how the Heaviside cover-up technique works. I take the number that will make the denominator under a equal to 0. That would be x equals minus 2. And I will cover up that factor here, and I will substitute x equal minus 2 into this expression. So I get a is equal to, this will be minus 2 minus 7 is minus 9. And when I put minus 2 down here, I will have minus 2 minus 1 is minus 3, and so we know that a is 3. That really didn't take very long. Similarly, with respect to b, the value of x that will make the denominator equal to 0 is 1. So I will cover up that factor over here, substitute 1, and we'll figure out that b is equal to 1 minus 7 is negative 6. And when I put 1 in the denominator, I get 3. So b is equal to minus 2. That means that the partial fraction decomposition of the problem we started with is 3 over x plus 2 minus 2 over x minus 1. And that's the way it will work for us. Here is a second example. Again, what we're going to do is factor the denominator completely. So this can be factored into a product of 3 factors. So in turn, we can have this as the partial fraction decomposition. Again, I only have linear factors, so I can do the Heaviside cover-up technique. So I can say, to make the denominator under a equal to 0, I can take x to be 0. I'll cover it up here, put x equals 0, and I will get 1 over minus 1 times 1, so a is equal to minus 1. b, to make that denominator equal to 0, I will take x to be 1. I will cover up that factor. I will put 1 in. Is 1 over 1 times 2, or b is 1/2. And under c, we see that if we take x to be minus 1, make that denominator equal to 0, we cover up that factor, and we substitute minus 1. So c is going to be equal to minus 1 times minus 2, or c is also equal to 1/2 as well. So the partial fraction decomposition for this problem would be minus 1 over x, 1/2 over x minus 1, plus 1/2 over x plus 1. This example is a little bit more complicated. Although we have a linear factor, we also have an irreducible quadratic form. And so this one is going to look different. Our expansion then will take this form. Now, we can use the Heaviside cover-up to figure out what a is. So what will make the denominator underneath a equal to 0 is 2. So I will cover up that factor, and I'll substitute 2 in for x. So I will get a is equal to, in the numerator, when I put 2 in there, I will get 16. In the denominator, when I put 2, I will get 8. So a is equal to 2. So now I know that a is equal to 2. Now I will get a common denominator. Now the common denominator is going to be the product of these two numbers, the same as it is on the other side. And I will be equating coefficients only with the numerator. So let's go through that. So here I will have to multiply top and bottom by x squared plus 4. And over here I will have to multiply top and bottom by x minus 2. And again, I'm only going to be worrying about equating the numerators. So I want 5x plus 6 to be equal to, and I will compare coefficients. Now here, the only squared will be with, well, there'll be two squareds. 2x squared there, and I will get bx squared here. So that'll be 2 plus b times x squared. But I did not see any x squareds on the left-hand side, so that means that b has to be minus 2. So now I know that b is minus 2. Similarly, I will look at my linear term, the term only with the x's on it. Now I don't have any linear terms here, but I do get a linear term here when I take bx times minus 2, and I get another linear term when I take c, when I expand it. So I am going to have that c minus 2b times x, and then my constant term is going to be 8 from here, and it's going to be minus 2c. So So again, I got b equal minus 2 from here. From here, I know that the constant term is 6, so I can say 8 minus 2c is equal to 6, and that means that c is equal to 1. So my solution here then is going to be 2 over x minus 2 minus 2x, because b was minus 2, over x squared plus 4, and then plus 1 over x squared plus 4, because c was 1. This problem is a bit different because in this problem I have a linear factor raised to a higher power. So my partial fraction decomposition will look like this. Now I can use the Heaviside cover-up technique here. I will say that a is equal to, the value that will make the denominator equal to 0 is minus 2, so I will cover up that one, and I will substitute minus 2, and I will get 1 over minus 3 whole squared, and so a is equal to 1 over 9. Now I can't use the Heaviside cover-up technique here because that would leave a 0 on the denominator on this side. So, but I can use it with this one, so I can take this one, x minus 1 squared, and I can take x to be 1, and I cover up that one. And I can substitute 1 in, and so I will get that c, the coefficient of the highest power, the one that I am covering up, is going to be 1 over 3. So I have 2 of the 3 already done. I cannot use that to find out what b is. So I have 1 over 9 x plus 2 plus an unknown b plus 1/3 over x minus 1 squared. Now what I'm going to do then is get a common denominator. I'm going to equate the numerators. So let's do that. So this is what the numerator will look like. I will multiply this one by top and bottom x minus 1 whole squared. b I will have to multiply by x plus 2 times 1 factor of x minus 1, and that one I will have to multiply by a factor of x plus 2. So when I start equating the coefficients, I can say I want to have a constant of 1. So let's look at all the constants of 1. Here, when I expand this, I'm going to get 1/9 times 1. So that is going to give me 1 over 9. And that was what I had on the other side as my constant. And here my constant is going to be minus 2b when I multiply all the way through. And here, when I multiply through, I will have 2/3. So this is what I'm solving for b, and I will get b is equal to minus 1 over 9. That means my solution is 1 over 9 over x plus 2 minus 1 over 9 over x minus 1 plus 1 over 3 over x minus 2 whole squared. Our next example is different than the previous examples in that we will have to do long division. And if I do long division, here's how it will work. This will go into this 3x times. I will subtract. Those will cancel out. I will bring this down. And now this then is this ratio that I have then is equal to 3x plus 7x minus 4 over x squared minus x. And I will factor that again. And this is what I'm going to be doing partial fraction decomposition on. Again, I can use the Heaviside cover-up technique, and so what I'm going to be doing is I'm going to be comparing. I'm going to be working to get this into an expansion, so I will say that this is equal to a over x plus b over x minus 1. So for a, I cover it up, I put 0 in, and I find that a is 4. And for b, I take b to be 1. I take the value of x to be 1. I cover up the factor, I put 1 in there, and I get b is 3. So now the answer to this problem then is the original expression was equal to 3x, that is the quotient, and then the partial fraction decomposition, 4 over x plus 3 over x minus 1. And that is our answer for this problem. Our last example is a little bit more involved, but at least we don't have to do long division, because the degree of the numerator is, this is being squared and squared, it's 4th power, and that's the 5th power, and the numerator is to the 4th power. So now we can expand this in terms of the linear factor plus, and here I have this factor is being squared, so I get one term that looks like this, and a second term that looks like this. So let's figure out what a is. So here I let the x to be 0. I cover up this factor. I substitute 0. Everything is 0 up there except for the 4 and 2 squared, and so a is equal to 1. So a is equal to 1, and we know this is then 1 over x plus Now I need to expand this, getting a common denominator, and the common denominator is going to be x times x squared plus 2 whole squared. So I need to multiply top and bottom here by, let's see, I've allowed myself some room. Here I have to multiply top and bottom first by x. That's going to change this to bx squared plus cx, and then times another factor of x squared plus 2, because I have to have a square in my common denominator. So here I will have and then here I will multiply top and bottom just by x. And I'm going to be equating coefficients here with the other side. So if I were to expand this expression, I would get and that was, these were times that. So Now, from this, I knew that A was 1. B is the coefficient of an x to the fourth, but I already have A being a coefficient of the x to the fourth, so I have 1 plus B. That means that B has to be 0. So B is equal to 0. And similarly, if I look, I see that I have a coefficient of 4 here and a coefficient of 4 there. Those could just drop out. I don't have to worry about those. And I can see that C is the coefficient of x cubed. That will and that's the only x cubed that I have. And so that says that C has to be equal to 3. And D is the coefficient of x squared. But the other coefficient of x squared is let's see, the only other coefficient of x squared is let's see, 4. So I already have a 4. 4 matches up with 4x squared. Sorry about that. So D has to be 0. And then I have to just make sure I know what the coefficient here is for E. And so I have the x's 2c plus E must line up with the x of 2. So 2c plus E has to equal 2. And we knew C was 3 already, so that is 6 plus, so E is going to be minus 4. Let's see, so that is 6 plus minus 4 is going to be equal to 2, so E is minus 4. And so we get this as our partial fraction decomposition. And so it goes relative to partial fraction decomposition. Remember that. Time is precious. Each day must count. Do the math. It will make you strong.